Hi, everyone. I'm excited to have you here for episode 753 of People Behind the Science. I'm your host, Dr. Marie McNeely, and today I'll be joined by our guest, Dr. Taylor Hutchison, to talk about life and science. I hope you enjoy getting a behind-the-scenes look into the life and experiences of another researcher in today's episode. And listeners, if you want to get to meet even more of today's scientists, you can check out our website at peoplebehindthescience.com or subscribe to our show on your favorite podcast platform. Today, Taylor is going to share some of her own insights and stories, so get ready to meet another one of our fantastic people behind the science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to People Behind the Science. Today, I am thrilled to be speaking with our guest scientist, Dr. Taylor Hutchison. So, Taylor, welcome to our show today. How are you?
I'm good. Thank you for having me here.
Well, Taylor, we are so happy to have you with us today, and I'm looking forward to learning more about you and the work that you do. But first, let me take a moment to tell our listeners a little bit more about your background. So, listeners, Taylor is an astrophysicist and a postdoctoral fellow at the NASA Goddard Space Flight Center. She received her bachelor's degree in physics from Southwestern University and her master's and PhD degrees in astronomy from Texas A&M University. Taylor was the recipient of the Dr. Joseph Newton Graduate Service Award, a University Prestigious Fellowship Scholarship, the Leadership in Equity and Diversity LEAD Award, and the Graduate Diversity Excellence Award from Texas A&M University. And she also received a National Science Foundation Graduate Research Fellowship as well. And today, Taylor, we're excited to hear more about your science, but also more about you. So can you first tell us, what do you like to do when you're not doing science?
Yeah, I have been described by friends before as a frenetic crafter. Mm-hmm. I like to collect different hobbies and build up different skill sets just for fun. So aside from the regular hobbies of enjoying reading and hiking and all of that, I also have taught myself how to sew my own clothing.
Oh, cool.
I like to take trash, like recycled cardboard and like newspapers and stuff, and turn them into usable things like baskets and different tools. So I have a lot of fun just kind of creating new things from stuff that would normally be thrown away.
I think that is amazing. And I love to hear that as a scientist, you also have this creative and crafty side of you, because I think people don't necessarily associate the two of them together.
Right.
Well, I love hearing about life outside the lab. You mentioned reading as one of the normal hobbies that you like to do, and we love talking about books on the show. So do you have a favorite book that you've read, or even just one that you've read recently and really enjoyed that you'd like to tell us about?
Yeah, actually, I'm really bad with coming up with favorites. My brain just refuses to come up with like a single thing. Mm-hmm. But as far as a book I've read recently, one that I found really fascinating, I'm not fully through it yet, but it's called Gone Tomorrow, The Hidden Life of Garbage. And it's from an American perspective, but, you know, as humans, we generate about 4.5 pounds of trash a day. And, you know, you put your trash in your trash can, you take it to the dumpster, and then it's out of sight, out of mind. But it really doesn't disappear. I mean, if you go down to the fundamentals of physics, you know, matter is neither created nor destroyed. It's not gone. It's just somewhere else. And what is the life cycle of that trash, and where does it end up? And it's a really interesting, the book dives into this whole discussion of climate and the way that, you know, the trash is ever growing, but like, how do we process it? How do we deal with it as a community? It's a really fascinating book. It's also a little bit sad, but it is a really good read. I would recommend it.
Well, fantastic recommendation. Listeners will have to pick up Gone Tomorrow, The Hidden Life of Garbage. I love this. And you mentioned that you love doing your science as well, and I would love to talk more about your scientific side. So let's get into some of the details. How do you describe your work to someone who's not in science or maybe outside of the field of astrophysics?
I love to describe it as I try and find and study the most distant galaxies we can possibly find. And this is a really fun and hard problem to have, because you're trying to find these galaxies that are really, really, really far away. Like the light that is emitted from them is traveling through the vastness of space for over billions of years to reach our telescopes. And so you need the biggest telescopes on the ground and in space to find them. So I'm really fortunate to have access to some amazing space observatories, like the JWST, which is a new telescope that we launched in 2021. And just trying to find these really distant galaxies and figure out anything I can about them. Like what kind of stars are inside of them? How many, many times more massive are they than our sun? What kind of elements are inside of these galaxies? In the very early universe, right after the Big Bang, you maybe have just hydrogen and helium. And it's a really bizarre baby galaxy time. And so trying to understand anything I can about that with the really amazing cutting edge technology is kind of the crux of the science that I do.
Very cool. And I look forward to getting into the details of some of the projects that you're working on. But let's talk about motivation. I think being able to explore these distant galaxies in space can be perhaps inherently motivational. But I know there are tough times in science, and it can help to have a quote or a saying or a mantra that goes through your mind to keep you going. So do you have a favorite, Taylor?
Like I said, I have a few favorites. One in particular, I think, it's a quote from Audre Lorde, which you become strong by doing the things that you need to be strong for. And I find that incredibly motivational. And it's always kind of been a mantra that I run in my brain, because you can often get bogged down by the hard things that happen in your career and also in life. And it's natural as a scientist, especially, to be facing challenges in your science and finding new ways to overcome it, or new data sets you need, or new just always trying to find different solutions to this puzzle that you have of trying to understand the cosmos. And it might feel overwhelming at points, but that is kind of the beauty of it, is you're overcoming this and you're growing stronger and more amazing as a scientist and more, skilled in all of this by approaching that hardship and trying to overcome it. And so I think that's probably one of my favorite quotes.
Fantastic. I love that one. And thinking about motivation and inspiration, I think a lot of the times it can come from people that you work with or people that you encounter in your life. So thinking about your own experiences, Taylor, do you have a particular role model or a mentor, whether it was a scientist or not, who really stands out in your mind as having a big impact on you in your career?
There are plenty of amazing scientists that I knew of or acknowledged or might have looked up to growing up. But the people, and when I reflect back, who are most influential for me as role models are actually my immediate family. I come from a lower income family with, 6 people. And so 3 siblings and 2 parents. And my parents are self-taught for the careers that they have now. They were not similar to the education that they did. So they did, website development and IT. And back at a time when it was really hard, Google this information. And so just kind of watching them teach themselves these skills and become incredibly talented and skillful with these careers. And then all me and my siblings having the same path of, we see this and we're very scrappy and we can figure this out. Nothing is impossible. As far as if we want to learn something, we will learn it. We will find a way. And so all of my siblings have careers that are very different from the educations that they had, but they're incredibly talented and skilled and living their best lives now. I think those were the most impactful things for me growing up is, just seeing this and knowing that if I want to do something, I can figure out a way to do it. It doesn't have to be the traditional path, but I will find a way to do it because I have lived this experience and I've seen my family do this as well.
Definitely. I think having those positive role models can have a big impact. And I think being determined as a scientist already is just a key character trait that I think a lot of scientists need to have. So I'm curious, you saw this sort of technology interest with programming and development in your parents. What originally turned your eye towards science specifically?
It's funny. I think it's partly a fascination with sci-fi and fantasy, especially with astronomy specifically, because it still feels like sci-fi, the work that I do. I think it also was a big part of it was puzzles, or that kind of concept of, the joy of really digging into something like a problem and finding a solution, and how, especially when it comes to math and physics, there's not necessarily just one solution. There's a ton of different ways to get to the same answer. And so I think it started early on. I really liked certain parts of math because I thought it was really fun, these puzzles that you can figure out. And then when I got to high school, I was introduced to physics and I was like, oh my gosh, physics uses my favorite parts of math. And so I got even more excited because physics also helps explain the world. And then I got to college trying to pursue physics and I met the one astrophysicist at my liberal arts university. And he was like, hey, you want to help out at the observatory? And then he showed me how astronomy and astrophysics use all of my favorite parts of physics and math. And they help explain the universe and how we got to this point. And so it kind of was a really natural progression of just being fascinated by the ethereal universe, but also, just this puzzle problem solving. That's just like a really fun thing to dive into.
Absolutely. And did you have an understanding then as an undergraduate when you were starting to get involved with astrophysics in terms of what research looked like or what a career in research could look like?
Not really, actually. It was an ever-growing experience. But definitely starting out undergrad, I got to help out at the observatory that we had on campus with like a 16-inch diameter telescope, which was very big to me at the time. I'm now incredibly spoiled by 30-foot wide telescopes.
Mm-hmm.
It was beautiful, though, getting to just get that taste of research, of, having these nights, many nights in a row throughout the summer, of opening up the telescope dome and using the telescope to look at distant galaxies and try and look at the supermassive black holes that were inside of them and see their effects on the galaxy around them. And that was just such a beautiful taste for me of what research could be. And my small contribution to it at the time, that's what made me hooked, was this is awesome. And I'm able to contribute to our understanding of the universe. And then getting to see even in more detail how directly I can do research and contribute. It was a very beautiful experience and a very growing understanding of what it means to do research.
Absolutely. And then how did you make the decision or sort of realize that it was part of the path to then pursue graduate school?
I definitely didn't know it was an option for me, even at undergrad level, until my final year. I worked to support myself through undergrad. At one point, I think I was working 4 jobs at once.
Oh, wow.
So I thought, at the very least, I know I can bartend. I'm good at that and I can make good money with it. I wasn't quite sure I could use my physics degree for it. And my final year of undergrad, my advisor, the same astrophysicist, sat me down. He's like, hey, something to consider. I don't know what you actually have planned. We should maybe talk about your career, but something I want you to think about is graduate school. And he kind of described to me a little bit about what it was. And that's how he got his PhD. And he thinks that I would be really a good fit for it. And that was kind of my first introduction to that concept, that that's something I could do. And I was kind of afraid of it at first and really didn't want to, because I was very tired after undergrad of just, doing both the full-time work and full-time school. But my mom begged me to apply to at least 2 in Texas, which is where I'm from. And so I did. And I was incredibly fortunate and very lucky to get into Texas A&M in that first round. And so that's honestly what got me into grad school, was 2 people believing in me and encouraging me to apply and happening to get in.
Oh, I think that can make all the difference, having those supporters around you throughout your career at these key transition points. And at Texas A&M University, can you talk about what your experience was like and kind of what solidified this path of academic research for you?
Yeah, it was so much fun. Graduate school is a really fascinating experience because it has, as I know you also have experienced, it's a challenge, and there are often hardships in it because it's an incredibly hard thing to do, but it is so rewarding at the same time. And being at A&M doing my PhD was really fun because it was it's still kind of a small program compared to other programs in the country and, around the world. But the people there were incredibly strong in the science that they do and really passionate about encouraging the next generation of scientists and helping train us to be their colleagues, which is kind of the point. And it was really awesome to be able to pursue the science I was interested in and have encouragement from my advisor and other faculty of, hey, you should lead this program you're interested in. You should apply for this telescope time, not me. And so if you get it, you are the, primary investigator. You are the person whose name is next to the time on that telescope, which are really big deals when you're in graduate school. That's not very common. And just kind of having that just very supportive, apply for everything, just like this really supportive environment was really wonderful. And they were also really supportive with anytime I wanted to do something to help improve my community, because I'm really passionate about the service I provide to my community is equally as important as the science that I accomplish. And so being able to create mentorship networks and, try and uplift the next generation of scientists and make it to where we can retain the people who do come in and have them feel valued and welcomed and have the resources accessible to them. All of that was possible at A&M. And so I'm really grateful I was able to go there. It was perfect, exactly what I needed.
Absolutely. And I think for a lot of people in astrophysics, a postdoctoral fellowship at NASA is like the dream. So how did this opportunity come about and what has it been like?
It's awesome. So definitely fortunate throughout my life to have the various opportunities or success with, applications for fellowships and things like that. And so, so for this particular one, I was in the job cycle, in the weeds of it, any postdoctoral job I could get, just this next little step after you get your PhD. It's usually like a 2 or 3 year position, at least in my field. And I didn't know until I was in the weeds of applying for jobs that I could even work at NASA with the science that I do. I didn't realize that was possible because in my mind, for my entire life, all I thought it was like, people who study exoplanets or study planets in our own solar system or very nearby galaxies, it makes sense that they'd work at NASA. But I didn't know that I could do that until I saw this job come across my desk of this NASA Postdoctoral Fellowship, like this very prestigious national fellowship. And one of the calls was very specifically about distant galaxies using our fancy new space telescope that was just launched. And so that was a really eye-opening experience for me to be like, oh, I could work there and I could do this. And that's awesome. And so it was really like a whirlwind moment of just figuring it out, applying, and then getting it, and just still kind of reeling from it. It was a very fast thing to happen, but it's been an amazing experience.
Wonderful. Now, can you tell us a little bit more about one of the projects that you're working on, something that you're super excited about at the moment?
Yes. So one of my most favorite parts about my current job is it's solely to do with the JWST, this really beautiful big gold space telescope that I say that we threw gently into space December 2021. And it has been running and taking data for the community for about a year and a half now, almost 2 years. And it is an amazing telescope. I could have, hours just waxing poetic about how fantastic and exquisite the data are from this amazing space observatory. And my fellowship is entirely to do with just data coming from that telescope. And so one of the things I'm most excited about is I work with a kind of data called spectroscopy, which I like to describe as like a light fingerprint. And the concept of a fingerprint where everything's unique. Every single cosmic object up in space has a unique light fingerprint. And that fingerprint can tell you about the chemical composition, like what kind of elements are inside of that galaxy or star. How big is it? What is it interacting with the nearby galaxies? What kind of stars? All of these really just fundamental, basic questions about what is going on inside of this distant galaxy. You can figure this out using spectroscopy or this light fingerprint. And I get to work with some of the most beautiful spectroscopy from this telescope. And it is such a joy to be able to just look through this. And I'm seeing the basic chemistry of a galaxy whose light has traveled over 12 billion years to get to me. And that is such a wild concept to me. And it's still, I can't believe that this is what I get to do. But that's really exciting to me. That's what I'm working on right now.
Absolutely. And I know this telescope you mentioned, you sort of threw it out in space, so to speak, and then it's been collecting data ever since.
Yeah.
I imagine there's a ton of data. How do you manage just the volume of data that you're working with?
Yes. I mean, even within just a year and a half, the data coming from this telescope, there's so much. And so part of it is you have these big international collaborations that ask for telescope time and get awarded. And some of these data sets are secret. They're hidden for just that collaboration for a certain, 18 months or so, and then they're public to the community. Some of these data sets are immediately public. And so there is a wealth of data out there way past what I just work with, where any scientist can come take this data and study it and look for new science to understand the universe. It's a really beautiful problem to have, but it is overwhelming how much data we already have. And just thinking of the future lifetime of this telescope, I think it was so beautifully efficient in every single step of getting out into space and getting it to its new home about 1 million miles from the Earth, that I think we have about 25 years of fuel to run this telescope, exceeding all expectations. And so we're already having so much data now to anticipate, 20 more years of this. It is an amazing problem, but it is also a little overwhelming at times in a beautiful way of just the amount of science you can do with these data sets will keep going for decades, I'm sure.
Sounds like you will not be out of a job anytime soon.
Not at all.
Well, Taylor, it's wonderful to hear more about what you're working on. And I know it's not all exciting projects and good news in science every day. Unfortunately, I think every scientist has these days where things go wrong, and oftentimes all at the same time. So do you have an example from your own experiences of a time where you really struggled with something, or perhaps you had a major failure? And if so, could you tell us more about how you worked through some of these challenges?
I have so many of these stories throughout my career. I think this is a really common, it's just a natural part of being a scientist. You encounter these various troubles or hardships, and you have to find either ways around them or new solutions. But one of the most recent ones that is also has a very satisfying conclusion is, again, to do with the space telescope, where within that first year of getting data for one of the international collaborations I'm a part of, this very particular kind of spectroscopy, this light fingerprint, the data were really hard to process. And what I mean by that is, imagine like with an audio recording, you record music or someone speaking, and then you might also record silence. And that silence is not actually silence. There's the noise of the microphone or the noise from the fridge in the next room, and you're subtracting out, you're removing that extra noise so that then the final recording is this crisp, clear, beautiful sound. The same thing with space data, where you're having to kind of remove the stray light from the sun or the heat from the instruments that are inside of the space telescope, just tons of things that you need to do to kind of clean and process the data so you can use it for science. Within this first year, for this particular type of data that we had, there was just not the machinery to properly clean this. And so it was really hard because you want to immediately do your science, but you have to clean the data first. And so we had to effectively invent the machinery ourselves for certain places in this process. And so it was really hard to do, and it took about a year. But myself and two of my collaborators at NASA, we worked on this and we created the machinery. And it was honestly a really wonderful collaborative experience. So it kind of a beautiful ending to this really hard time. And we invented effectively this new way in computer programming code to fix this problem. And it's been a resource for the community ever since. But that was a really interesting example of, having this hardship that you have to go through, or this issue or challenge, and through the work of the community kind of overcoming it and finding a way to get to the solution.
Oh, very cool. And I love the analog that you drew there with the audio processing. And I think when you're working with something like audio processing, it's easy to tell what's noise and what's not noise, because if it's noise, you take it out and it's silent. How do you know sort of what the comparable thing for noise would be? What do you take out? What don't you want to take out when you're working with the kind of spectroscopy data that you're working with?
It is an active field of study in some cases, especially when you have a new telescope, because you have, some expectation of some of the noise you might get from various things. Like I mentioned, stray light from the sun, or the instruments themselves, like being hot. But you have the things that you've measured in a laboratory before you've launched it into space. But now that it's in space, there's new stuff that you weren't anticipating that you now have to correct for. And to some degree, you have noise or extra stuff you already expect, and then you have the unexpected as well. And so trying to figure out what the unexpected is, I think it's a fun problem, but many would argue it's a horrible problem. It depends on what interests you, right? I love these puzzles, and so I think it's fun. It's a fun challenge. But yeah, it's many, many brilliant people coming up with different tests and different ways to figure it out. Like, what additional things are there that we weren't anticipating, and how do we remove that extra noise? What's it coming from? How do you get it out of there? Definitely still an active field of study in the community, still having many discussions on the best way to clean these data products.
Very cool. And I think it's awesome that you're able to work really on the edge of what is known and unknown in this space, so to speak.
Yeah, no, it's pretty fun.
Yeah, we'll sneak in some puns here and there. But I think that is one of the things that really makes science exciting is, like you said, being able to solve these problems and being able to discover things that are new, develop these new methods. And it sounds like you said this had a happy resolution, and we love celebrating the successes in science. So do you have a success story that you can share with us, whether it was one of these big wins, Taylor, or maybe one of these small but meaningful victories that you've experienced in your own career?
One success that I'm really proud of, it's not necessarily science-based, but when applying for the job cycle at the end of my graduate school career, it's a really hard thing to do. Anyone who's gone through it, as you also, I'm sure, know, it's really hard to do. It's really draining. You're having to compare yourself to your peers, even though we should never do that. You're having to look back on your career and trying to figure out how to best prove to people you want to work with that you are worth hiring. It's a really interesting problem. But I noticed when I was going through it that so many people were really kind and giving me, advice and just lots of feedback. And there were tools I was developing. And I realized that there wasn't like a repository of tools for everyone. If you had good mentorship or you had people who could share resources with you, you were much better off in the job cycle than those who did not have access to these same kind of resources. And so something I did was I kind of compiled everything that was shared with me and everything that I made into like this massive resource for academic postdocs in astronomy and astrophysics, and shared it with the community. And at the time, I wasn't really expecting it to be helpful for everyone. I just thought, hey, this is me compiling everything that I use and what helped me become a successful postdoc. So here, everyone, in case this is useful for you. And I feel like the win part of this was, I shared this maybe 2 years ago at this point. I still to this day have people corner me at conferences or message me through social medias or email me telling me how useful this resource was for them in applying for their postdoc jobs. It's what got them into their next job. And it's been such a beautiful experience to see that it's actually been really helpful for lots of people. And so that's like a win that I keep feeling like it's a continuing win. And it's a really wonderful thing that is still happening.
Well, it sounds like this resource has been valuable for a lot of different people in the community. And I think you're absolutely right to sort of identify these gaps. A lot of times I feel like we're always recreating the wheel for a lot of the things that we do unnecessarily. But like you said, if you had aggregated those resources, why not make them available for others, particularly now that you had your cushy postdoc position, right?
Yes, exactly. And I remember part of the reason I even had the thought was I was helping some of my friends apply for their postdocs and like reading their applications and realizing and editing them and helping them. And one of them telling me, "This is amazing. Thank you so much. I've had no help so far. Like, you were the first person to help me. And like, I don't even know where to look for help." And so one of the inspirations for creating this resource was, just to try and remove that barrier and make it so that no one has to suffer through that.
Absolutely. Well, I applaud those efforts. And I think this is something we'd love to see more and more of in science, not just in research, kind of in terms of the open source movement and making things publicly accessible, but also some of these tools and strategies and just having candid conversations about what needs to happen for people to have successful careers. I think that's critically important.
Absolutely.
And then another thing I'd love to chat about are scientific travel opportunities. I think we've talked about some of the phenomenal things about being able to be a scientist, but for you specifically, Taylor, have you had opportunities to travel to various places, whether it's for meetings and conferences that people are cornering you at or just to present your work to other people? So do you have a favorite place that your science has taken you?
Yeah, I didn't realize in this field how much I travel. And it's more for just conferences, like you said, but also going to big telescopes around the world and using them. Going to these big telescopes on the ground during my graduate school career, before the fancy space telescope that I used was launched. Honestly, my favorite place so far that I've ever been for work is Chile, near the Atacama Desert, where it's this incredibly low humidity area of Chile where we have lots of telescopes. And I went to the CTIO, which is this really big observatory on top of one of the big mountains there. And I got to live there for 2 weeks and work on some instrumentation on one of the telescopes, like updating it with some colleagues, and then starting the observations for this really big international collaboration. And just being up there on that mountain for 2 weeks and every sunset, getting to watch the sunset down over the horizon of these massive range of mountains. And it was a beautiful, amazing experience and very ethereal almost, and how it was just me and the cosmos every night.
Oh, that sounds absolutely amazing. Now, was this one of your first international travel experiences, or had you been other places before?
Honestly, yeah, it was. I think I had gone to another country to visit a sibling who was teaching English there. But aside from that, this was my first actual international trip, and it was just beautiful.
Oh, that sounds remarkable. And was it intimidating for you, like you said, going to this observatory in another country, being sort of launched almost into the deep end, just starting to work on some of the instrumentation that you mentioned there at this relatively early stage of your career?
Yes, absolutely. I think this was so I did 6 years for my PhD, and this was in my third year, I think. So I still felt very fresh, very, very much like a novice, that I got to go with a faculty member and an engineer from our department. And so it was really beautiful to be able to participate in doing this work and also get to learn from them at the same time. And so it definitely was intimidating, but it also was really exciting. And I felt very official. I felt like a real scientist at that moment.
One of those I've made it moments.
Yes, exactly.
Definitely. Now, did you have any time to explore Chile or the Atacama Desert while you were there?
Unfortunately, no. So when we arrive at La Serena, which is like a small town near the coast. And so we got to hang out there for one night and eat delicious food and drink pisco sours, which is astronomer drink of choice in Chile. But aside from that, it was just a straight shoot up to the top of the mountain, to the observatory, and then back to the airport. So next time I go, I would love to spend more time and just explore a little bit more because it's incredibly beautiful down there.
Absolutely. Well, this sounds like a phenomenal travel experience. And I think in addition to being able to see all of these different places around the world when you're going to do your science, I think one of the other things that's wonderful about science is that you get to work with scientists and people from all over the world. And I think particularly in your field, there are a lot of these big collaborative projects. And I know scientists are often portrayed in the media as being a particular way. There are some stereotypes out there about scientists as being very serious and critical and always working in the lab in their white coat. But I think that's just not the case for so many people that I know who are scientists. So do you have an example, Taylor, of maybe a quirky lab tradition that you experienced, or just one of these fun or funny human moments in science that you can tell us about that goes against some of these stereotypes?
Gosh, so many, because everyone I know in science is incredibly funny and quirky, and it's just very silly, brilliant people. And I think one that I really loved was actually from graduate school. And just occasionally, it was never like a planned thing, but occasionally the graduate student cohort, about 18 of us, they would just randomly start to have these competitions on cooking. So there would be like these cooking bake-offs effectively of, who makes the best soup, or who makes the best jollof, or who makes the best, just insert some kind of cuisine, and everyone would compete and make their own versions of it. And then all the other grad students would come and we taste it and we vote on it. And it was very silly and very fun, and also just delicious food, which is, always a good thing, especially in grad school.
Oh, yeah.
Yeah, I always really enjoyed that.
Now, were you an expert chef at that point in your life?
Absolutely not. I do enjoy experimenting, though. That's probably one of my other fun hobbies. And unfortunately, what that means, it's a very astronomer thing to have your brain turn on at night. I'll start experimenting at 10 p.m. on nights, and then would be done experimenting at like 2 a.m., which is not a good time to be experimenting because you should be sleeping. But, it's a very astronomer thing to do.
I love it. Well, do you have a particular cuisine that you like to play with or experiment with in the kitchen?
I do. I'm a really big fan in a similar way to how I like to craft with, reusing cardboard and newspapers and other things so that they don't immediately go to the trash. I also really enjoy finding ways to do zero waste cooking. And so, what that might mean is, if you use a lemon, squeeze the juice of it into something, usually people will throw away the lemon rind, but you can actually scoop that out, slice it, boil it a few times, put it with sugar, and it becomes a little gummy worm, like a very delicious edible gummy worm. Or you can put it in a cleaning product. Different ways to reuse every part of food that you're using so that none of it's being wasted, because food waste is a really big issue. And so my experiments are kind of in that vein of how can I reuse this part of the food I was using or the product I was making food out of so that there is limiting food waste as much as possible.
I think that is phenomenal. I love that. Well, Taylor, when you think about some of the unanswered questions in your field, I know there are many. So if we took away the barriers that normally hold you back, whether that's funding, staff, technology, feasibility, telescope time, whatever it might be, do you have one particular question that's just burning in your mind that would be the one that you would want to answer most?
Let's pretend for a moment that an eternity could happen in a second.
Mm-hmm.
And I could use some fancy space telescope that's incredibly massive, like the size of the Earth or something, to take spectroscopy or light fingerprints of distant objects. I would love to take a spectroscopy of every single thing in the entire sky and the entire observable universe. I want all of the chemistry from every single cosmic object. I would love to be able to go down to the individual atoms that are being formed inside the cores of distant stars and these really massive galaxies that we have no idea what's going on inside of them. I'd love to be able to peer into it even deeper. And so maybe less of an actual science question and more, I want light fingerprints of everything, detailed light fingerprints. I just want all the spectroscopy ever would be my goal.
And all of the time possible to analyze it, right?
And all of the time to do all of that.
Oh, that sounds amazing. I love this dream question. I think it's important to dream big because oftentimes I think scientists do limit themselves, and it can be helpful to take a moment to think outside the box of what you could possibly answer if there were no barriers.
Exactly.
And I think in science, it can be helpful to also get advice from others in the field or from others outside of the field even as well. So when you think back about your career, Taylor, is there a particular piece of advice that somebody gave you at some point that really helped you that you can pay forward and share with listeners today?
It's hard to pick a favorite. I will say, I think one phrase or quote that I remember is from a book by James Baldwin. And he says something like, those who say it can't be done are usually interrupted by others doing it, or something like that. And I love that. And that's been some guiding advice throughout my life of, never let that be your limitation. I've had many times in my career where people tell me, oh, you can't do this. It can't be done. I mean, even with one of the fellowships I received in graduate school, the National Science Foundation Fellowship, it's this, prestigious national level thing. And it's really hard to get. I was incredibly fortunate. But when I was originally planning to apply for it, I had people, even faculty, tell me, don't even bother. They won't give it to you. They won't give it to anyone who's not on an East Coast school or West Coast school. And I remember remembering that quote in my head at that moment and being like, no, I'm going to do it anyway. Because why would I not do something just because you say I can't do it? And then I happened to get it. And now they don't say that advice anymore. They tell everyone to apply for it. So it is kind of a guiding advice that I share with people.
Well, I love that advice. I think making sure you're not self-excluding from opportunities that you're excited about or that you're interested in is really important.
Exactly.
Well, Taylor, it's been wonderful to chat with you. Thinking about your career, thinking about the wonderful work that you get to do you have another piece of advice or any last piece of inspiration that you would like to share with our listeners today?
One thing I would say is just stay creative and curious and find joy. I know that sometimes, especially as a scientist, you can get bogged down in the weeds of the work that you're doing or the data that you're cleaning or, whatever it is, the analysis that you're trying to do. And it can be kind of hard to remember the reason that you got into this and the passion that made you want to get into science, or even separately from your job, just finding things that bring you joy and really reveling in that and making time for it, I think is super important because we exist outside of the career that you're kind of defined by or the people that you're around. You have so many beautiful facets to who we are as humans and as scientists. And I think really just making a point to try and find that joy is so important and so affirming and really helps me stay creative and happy in the work that I'm doing as well.
I think that's a wonderful message to leave everyone with. Thank you so much for sharing all of these wonderful advice and your insights with our listeners today. If they want to learn more about you and the wonderful work that you're doing, what is the best way for them to do so?
I definitely recommend, if anyone's interested, you can check out my professional website. It is tx.ag/Taylor, Taylor. And I share tons of science on there, all the resources I make, resources other people have made, fun links to other, outreach talks I've given, just lots of really fun stuff. Pictures from my travels for work. I put a lot of stuff on there. So if anyone wants to learn more, definitely it's a fun place to explore.
Fantastic. Well, Taylor, we appreciate you sharing those resources. Listeners, definitely check out her website to learn more about her and the wonderful work that she's doing. And Taylor, it's been such a pleasure to have you on the show today. Thank you so much for your time.
Thank you for having me. This has been wonderful.
It's been great to chat with you, and listeners, always wonderful to have you here with us. We hope you'll join us again for our next episode of People Behind the Science.